All right, today we're going to talk and sort of work through section 2.8. This does tend to be a long section on a video because we take almost 2 days. We take a day and a half to cover this in class. So you have to bear with me through the end of this. It may get a little bit elongated, but we'll do our best here. Linear equalities. We've been talking about linear equations, and the difference today in linear inequalities is that they're going to have a special sign. So what we've been talking about is equations. They look like this, right? They have an equal sign in them. Inequalities don't have an equal sign. They have this sign that I have highlighted, or any of these four signs. These are called inequalities. I've got these labeled on the next page of the next, but looking at them individually, we have the less than symbol, the less than or equal to, the greater than, and the greater than or equal to. It'll take you a long way just to memorize the words that go along with those, right, and what they mean. If you can, memorize those four words. Less than or equal to, greater than or equal to. When we get ready to try and find a solution of an inequality, there's a couple of ways that we're going to write that solution. One's going to be set notation, set builder notation. The other is going to be interval notation. And most of the times you're going to be asked to graph them as well. The graph helps to find the set builder notation and the interval notation, so I would recommend for all problems to graph them first and then try and write out your set builder or your interval notation. For a regular equation where you just get x equals a number, if you looked at that on a number line, it's just going to be a dot on that number line, right? We solve an equation, we get x equals 2, it's just that dot. For an inequality, x is greater than or equal to might be our solution. And that's going to be not just a dot, but it's going to be a shaded area on the number line. I've got our inequality signs labeled down here on the bottom. If you look at this chart, this is our greater than symbol, our less than symbol. The greater than and less than symbol are notated with an open circle on our number line. Typically, we would have an open circle or a parentheses, okay? We're going to see it both ways on a number line. When we get ready to write our interval notation, it will also have parentheses if we're talking about greater than or less than. The greater than or equal to and less than or equal to, those are notated with a closed dot on the number line. You see that here? And they can also be notated with brackets. They can be notated with brackets on the number line. They could also be notated with brackets in our interval notation when we get ready to write that. So if you were to write down anything off this slide, I would absolutely write down this chart. This chart is going to help us throughout the lesson. I'm going to refer back to the chart, but I'm not going to write the chart back out a whole bunch of times. So take your time now, write down the chart so that you can refer back to it. Here's an example. If we have, for example, x is greater than 2, we would start by saying that that is going to be a parentheses, right? Because it's greater than if we look at the chart. And since x is greater than 2, we're looking for things bigger than 2, and so we would shade to the right. So starting with a parentheses and shading to the right. X is strictly greater than 2. This can also be an open circle, not a closed circle, an open circle shaded to the right of 2. Both of these mean the same exact thing. If instead I had greater than or equal to, I would have had to put a closed circle or a bracket instead of a parentheses. Here, since it's strictly greater than, not greater than or equal to, I have to notate that with a parentheses or an open circle. All right, let's try these, graphing these solution sets. X is greater than -1. So we'll put -1 on our number line, maybe put a few other numbers for context. Greater than -1 means I'm either going to have a parentheses or an open circle. Greater than means I need to shade to the right. Remember I said memorizing the words that go along with those symbols will take you a long way. It really helps with the graphing. C is greater than or equal to 7/3. If I type 7/3 in my calculator, I actually get the number 2.333 ... That gives me an idea of where that number is on a number line. So it's between 2 and 3. 0, 1, 2, 3, 4. That number's somewhere between those two. And I'm going to have a closed circle because it's greater than or equal to. I'm sorry, it's less than or equal to. This symbol right here is less than or equal to. Being less than or equal to, I'm going to shade to the left. Something I tell my classes as well is that as long as the variable is on the left side, this little arrow is going to point which way to shade. So on this one, the x was on the left side. The arrow points to the right. We need a shade to the right. That's only true if the variable is on the left. So on this last one here, the variable is not on the left. We cannot use that method. 3 is greater than y. I'm going to give us some context. 4, 5, 2, 1. Since it's strictly greater than, I have to use an open circle. And 3 is greater than y. That means y has to be less than 3. 3 is greater than y. That means y is somewhere over here. All of these I could have written, instead of circles, I could have written with parentheses. On Alex, it will ask it for one way and the other, right? It just depends on the problem. So this problem I would have written with a parentheses. This one I would have written with a bracket. And this one I would have written with a parentheses. It just depends on the way Alex asks. All right, take a second. I would pause the video and see if you can do these three. And I'm going to buzz through these quickly here. Y is less than 0. That would be an open circle. And y is less than 0, shading to the left. X is greater than or equal to negative 5 over 4. If I type negative 5 over 4 in my calculator, I get negative 1.25. That's between negative 1 and negative 2, and I'm going to have a closed circle or a bracket, right? It could have been a parentheses on the first. This one could be a bracket. And I'm going to shade to the right because x is greater than or equal to. The or equal to means that that number is included in our solutions, right? That's why it has a closed circle. And the third one, 5, is greater than or equal to a. That's going to be a closed circle, or it could be a bracket. 5 being greater than a means a must be less than 5. 5 is greater than these numbers over here that I'm shading. 5 is greater than 3. It's greater than 4. All right, like I said, an open circle or a closed circle are the same exact thing. They mean the same thing as a parentheses or a bracket. It just depends on how the question's asked. So this one could be a bracket. This one could be a parentheses. If you have a variable in between two numbers, sandwiched between, then you're going to shade between those numbers. So here, y being between negative 4.1 and negative 1.7 means I'm going to shade between negative 4.1 and negative 1.7. Notice that they have different symbols. The negative 4.1 was strictly a less than sign, so it had a parentheses. The 1.7 has the greater than or equal to, less than or equal to, I'm saying I'm backwards now, and that means it needs the bracket. Whichever one it's closest to here is the distinction. So this one is closer to the less than, this one is closer to the less than or equal to. On this one, I do something very similar. Notice that they both have a less than or equal to. And so the 0 is going to get a closed circle. The 8.5 is going to get a closed circle as well. And since y is sandwiched between, I'm going to shade between those two numbers. Again, closed circles and brackets, they mean the same thing when we're shading these. I could have done this with closed brackets facing inwards and shaded between the closed brackets instead of the circles. All right, now we talk about how we're going to write our solution. So we get things like x is greater than or equal to 2 as a solution, okay? Set builder notation, this is what set builder notation is. It always starts with and ends with these swirly braces, okay? It always starts with and ends with the swirly braces. The first thing inside the swirly braces is the variable that you're dealing with. If we had p is less than or equal to 2, this right here would have to be a p. It's whatever variable is in your problem. The very next thing after that is always going to be a vertical bar. How this reads is, this is the set of x such that some condition is true, okay? So in our case, what we have is the set of x such that x is greater than or equal to 2. Our solution is all the x that fit this category. We can also write our answers in interval notation. Interval notation is a little bit more difficult for some people to write. And what we're going to do is we're going to use the same parentheses and brackets that we've been using, and we're going to write our answer out from left to right. Okay, so this one, we're just describing the shaded area. This one is shaded from 2 all the way to the end of the graph. It's shaded from 2 to the end. So we're going to say it's shaded from 2. And since 2 has a bracket here, we're going to put a bracket on the 2. If it had a closed circle, we would also put a bracket on the 2, showing that the 2 is included. And it's shaded from 2 all the way to the end of the graph at infinity. If you go to the end of the graph, you're either going to use positive infinity or negative infinity. I can show you that here. To the right side is always your positive infinity, and to the left side is always your negative infinity. Here, I'll get a different color here so you can see it a little better. Right side's always positive infinity, left side's always negative infinity. Infinity is always going to come with a parentheses, and infinity can never have a bracket on it because we think about the number is included, and infinity is not a number, okay? It's a value. It's saying that we can take the largest number that we possibly can find and sub it in, and it will be true. We can't sub in infinity, though. So the infinity itself, infinity is always going to have a parentheses. Also, I mentioned this on the last one. Your interval notation, regardless of where it is always going to be written from left to right. We're reading it from left to right. Looking at these as an example, this one's shaded from A to infinity. This one's shaded from negative infinity to A. This one's shaded from A to B, reading left to right. And the final one shaded from A to B. Notice the parentheses and the brackets match up. This is your interval notation solution. The parentheses and brackets match up with what is on the graph. That's why I was saying earlier, for all these questions, it's easiest to graph it first if you can. Let's write these in set builder and interval notation, okay? We're trying to do both. So I'm just going to make a set builder interval, okay? So for question number 5, our set builder notation. Remember, set builder always has the swirly brace, the set of x such that, and every number that's shaded here is greater than or equal to -2. You see that? The bracket means or equal to. If we were using interval notation, this is shaded from -2 to infinity. So our interval notation is everything from -2 to infinity. On question 6, let's do the same thing. Question 6, this was question 5. On question 6, x is less than 3 over 2. Remember, if you can graph it, you should absolutely do that. 3 over 2 is somewhere in here. It's between 1 and 2. If I type it in my calculator, it's 1.5. And x is less than, that means we're shading this way. X is less than 3 over 2. So my set builder notation is the set of x such that this condition is true, as x is less than 3 over 2. And my interval notation, I'm shaded from left to right from -infinity to 3 over 2. Remember, I'm going from left to right, from here to there. I put a parentheses because the 3 over 2 is not included. Remember here, the less than, strictly less than, means I have to use an open circle, means I have to use parentheses. All right, this last one is the toughest. Number 7. Here, I'll give us a little bit more space on 7. Our set builder notation is the set of x such that, notice our x is sandwiched between those two numbers. And remember, we wrote that as -3 less than x less than 1. Since our 1 has a bracket on it, we're actually going to say less than or equal to 1 there. This had a parenthesis, so we're just saying less than. -3 is less than x is less than or equal to 1. That's going to go in our set builder notation. -3 less than x less than or equal to 1. And then our interval notation, where is it shaded? It's shaded from -3 to 1, right? Going left to right, it's shaded from -3 to 1. -3 to 1. It has a parenthesis on the -3, and it has a bracket on the 1. Always with interval notation, we're reading left to right. Solving inequalities works the same way as solving equations. The only difference is how we write our answer. So we can write our answer in either set builder or interval notation. this question actually tells us to express the solution in set builder and interval notation, so we'll do both. All right, so if this was an equation, the first thing we do is try and collect our p's. So I'm going to say plus 3p. That leaves me with p plus 5 less than 6. Subtract the 5. That leaves me with p less than 6. Notice I left this alone the whole way through. There's only one situation in which you need to change that, really. I left that alone the whole way through. I'm going to tell you when to change that in a minute. P less than 6. Before we start to write out our set builder and interval notation, let's see if we can get it graphed. 6, 7, 5, 4, 8. Give it a little context. This is less than, strictly less than, so an open circle, and we're shading P as less than 6. 5 and 4 are both less than 6. Now our set builder notation is going to be the set of, here we're dealing with P, not X. You see that? That matters. Whatever variable you're using goes here. The set of P such that P is less than 6. Ooh, my bracket got a little squirrely there. And our interval notation is going to be, it's shaded everything from negative infinity all the way to 6. From negative infinity to 6. Remember, infinity always gets a parentheses. Even if the other item has a bracket, the infinity is never going to have a bracket. It's always going to have a parentheses. Take a second, pause the video, and see if you can do this one. I'm going to uncover my work here in about 3 seconds. So here's how I solve the problem. Here's what my graph looks like. And if y is less than, strictly less than, negative 6, it's going to be an open circle, shaded to the left. My set builder notation is going to be the set of y, because that's my variable, such that y is less than negative 6. I'm basically just taking my solution and rewriting it. My interval notation, this graph is shaded from negative infinity to negative 6. So from negative infinity to negative 6, infinity always gets a parentheses. Here, since I had an open circle, my 6 is also going to get a parentheses. All right, here's the one situation where you do have to flip the sign. Notice on this, I did not flip that less than sign the whole way through. On this one, we start it, we add 3 to both sides. If you ever multiply or divide by a negative number on both sides, right? If you multiply or divide by a negative number on both sides, then you have to flip your sign. If you divide or multiply by a negative on both sides, then your inequality has to flip. That's something I would absolutely write down. So here, if I divide by negative 5, I divided by a negative on both sides, you see that? Then my inequality sign has to flip. It went from a less than or equal to a greater than or equal to. All right, on this one, negative 3, negative 2, negative 4, close circle because it's greater than or equal to, and since it's greater than or equal to, I'm going to shade to the right. Our set builder notation is the set of x such that x is greater than or equal to negative 3. That's our set builder. Our interval notation is shaded everything from negative 3 to infinity. Infinity gets a parentheses. Since the negative 3 has a closed circle, it's going to get a bracket, right? Any closed circle always matches with a bracket. Notice this answer has a bracket and a parentheses. That's because our negative 3 had a closed circle. Infinity can never have a bracket. Try this one. Very similar to the last one. I'm going to uncover my answer here. This is how I solved it. Remember, you can pause these videos at any point. This is what my graph looks like. P is less than negative 4. My set builder notation and interval notation. From here, we just add more steps, okay? So again, you could take your time, pause the video, start by distributing, and try and solve this. This is my process of solving. This is what my graph looks like. Set builder notation, interval notation. On inequalities with fractions, I told you in class, we're going to treat every problem with fractions the same way. The same thing goes with inequalities. So if you have fractions, let's clear the fractions first. On this question with fractions, we're going to multiply by 4, 6, and 3. 4, 6, and 3. 4, 6, and 3. 4, 6, and 3 to every single term. And then anything that matches up top to bottom, remember, you will get rid of. That's the purpose. That 2 there, it does get multiplied, but there's nothing to get rid of. You see it? All right, what's left, we're going to multiply. So 6 times 3 times negative 1 times k, that'd be negative 18k. Let me get my black pen here. Negative 18k plus 6 times 3 is 18. Oh, that's 4 times 3. I'm sorry, I marked the wrong thing out there. I'm glad I noticed that before we got any further. So here, 4, 6, and 3. I should have marked out my 6. So 4 times 3 would make 12 there. Less than or equal to 4 times 6 times 3 times 2. 4 times 6 times 3 times 2. And my calculator tells me that is 144 plus 2 times 4 times 6 times k. 2 times 4 times 6 would be 48k. And now from this point, we have a problem that looks very much like the last one. I would again recommend pausing the video and seeing if you could get to the end. We'll work this down to the end. We won't write out the set builder and interval notation here. The main point of this problem was to get rid of the fractions. So here I could subtract 48k. You could also have added 18k. Negative 18 minus 48 is negative 66k. Plus 12, less than or equal to 144. Subtract the 12. Negative 66k, less than or equal to 132. We ended up in a great situation here where we divide by the negative 66. Remember, if you divide by a negative, your sign has to flip, and that ends up being just a regular negative 2. Great news. We got a nice answer. Our set builder notation, we said we were not going to do it, but it would be the set of k such that k greater than or equal to negative 2. Our graph would be everything to the right of negative 2. And so our interval notation is going to end up being everything shaded from negative 2 to infinity. And notice I put a parentheses. I should have had a bracket there because it's a closed circle, right? It is included. That is a greater than or equal to. All right, try this one. I'm going to uncover my work here. That's what my work looked like. This is what my graph looks like. My set builder notation and interval notation. All right, when you have a compound inequality, that means, look at this, I have an inequality here and an inequality there. We've already seen that the graph is going to be sandwiched in between. When we go to add, subtract to get x by itself, we still want x by itself. We just have to do it in all 3 of these zones now, in the left, the middle, and the right. So anything we do to the middle, we have to also do to the left and the right. Here, the first thing I want to do to get x by itself is subtract the 1. So I have to do that in all 3 positions here. Negative 4 less than or equal to 2x less than 7 minus 1 is 6. I still want x by itself, so I can divide by 2. That means I have to do it in all 3 places. Negative 2 less than or equal to x less than 3. Again, the same thing applies where I don't flip that sign unless I multiply or divide by a negative. My set builder notation, instead of writing this whole thing out, again, I'm just going to say it's the set of x such that this is true. My graph is going to be everything shaded between negative 2 and positive 3. And so the negative 2 is going to get a closed circle because of that less than or equal to. The 3 is going to get an open circle because of that less than. And I'm going to shade in between. And so my interval notation is everything from negative 2 to 3. That's where I'm shaded from left to right. The negative 2 gets a bracket. The 3 gets a parentheses. try this one. I'm going to uncover my answers in 3, 2, 1. That's how I solved it. I got y between 1 and 8. So then when I go to graph it, I need to have a closed circle on the 1, an open circle on the 8, and shade between. Remember for all of these that instead of having an open and closed circle, I actually could use brackets and parentheses. I could alternate between the two. Alex is going to ask you sometimes to do one and sometimes to do the other. Set builder notation is the set of y such that 1 less than or equal to y less than 8, right? Y. I'm just essentially rewriting my solution in this notation, in this format. My interval notation is everything from 1 to 8. 1 included, 8 not included. All right, for word problems, I would take a second again and write down these words. I would pause the video, write down the words. The words make sense in the problem. So A is less than B means I'm going to have just a less than sign. Greater than or exceeds, greater than sign, and so on. I'll give you a second to write these down. For all of these, all we're trying to do is write the English phrase, okay? We're trying to write it. We're not trying to solve it. It says write the English phrase. So first, Claude's annual salary is no more than $75,000. If you go back to look at your chart, no more than, right here, means less than or equal to. So here, his salary, S, is less than or equal to $75,000. For B, a citizen must be at least 18. So his age has to be at least 18. That again came from the chart. An amusement park has a height requirement between, and take a guess what between means. That means that our height is between 48 and 70. It doesn't tell us whether they can be 48 inches or be 70 inches. So let's say 48 is less than, H is less than 70. Here, I would accept less than or equal to. It doesn't really give us enough information to tell us whether they can be exactly 48 or exactly 70. I would say here between, I would read that as strictly less than. Again, if you wrote on your test less than or equal to, I'd accept it. All right, finally, last word problem here. To earn an A in a math class, Algebra must average a 90 on all of her tests. She has to average a 90. If you remember how to find an average, if I had 4 tests, I would say test 1 plus test 2 plus test 3 plus test 4, all over 4. That's how you find an average. You add up all the tests, divide by how many there are. All right, it says her average has to be a 90, and it gives us her first 5 test scores, a 79, a 86, a 93, a 90, and a 95. We want to figure out what score she needs on the 6th test. So we don't know what that is. Let's call it X to get an A in the class. Okay, when it says she has to have at least a 90, that means her average has to be greater than or equal to a 90. You can again go back to that chart and find at least means greater than or equal to. If we average up all her tests, it says she's going to have 6 tests total. Her first 5 tests were a 79, a 86, a 93, a 90, a 95. And her last test, we don't know what it is. Let's see if we can solve this. All those numbers on the top, let's add those up in the calculator. 79 plus 86 plus 93 plus 90 plus 95. If we add those up, we get 443 plus X over 6 greater than or equal to 90. Again, any problem with fractions, you can get rid of the fractions in the same way. We're just going to multiply by the same thing on both sides. Just so happens on the left side it will go away, and we'll be left with just our 443 plus X. And on the right, 90 times 6 would be 540. To solve for X, we need to subtract 443. And 540 minus 443, 540 minus 443 is going to be, we didn't multiply or divide by a negative, so our sign stays the same, a 97. So Alsha needs greater than or equal to a 97. She needs at least a 97 on that test to maintain an A. All right, I hope you got something out of this. Feel free to ask questions via email or ask me in class.